Hello viewers and welcome to iTTV. We are once again going to start another lesson in Maths, and I do hope that these video lessons have been able to help you to understand the topics better, and that we can continue to help you to understand your maths better too. In this lesson, we are moving on to another subtopic in Chapter 1 of the Form 4 Additional Mathematics, and that's the chapter on functions. In this lesson, we're going to look at functions in more detail. What we have studied in previous lessons was the concept of relations, and then we moved on to a more detailed investigation where functions is a special type of relation. Expressing functions using function notation. Even as functions go, we have to understand that they are made up of either two types of relations only, either one-to-one relation or many-to-one relation. Now, all this was discussed in previous lessons, and what we're now at is knowing how to express functions in notation form. This means, how do we write out the wordings that will show us the way to describe the function. Let's take a look at an example which was covered in the last lesson, but it helps us to remember how to write out function notation. The function of the following relation, and you do see, viewers, the diagrammatic form where the objects are -1, 0, 1 and 2, and through the relation of 2x, we will obtain the image values of -2, 0, 2 and 4 respectively. Now, this function notation can be written as follows. Either part 1, it should be written as the function f maps x to 2x, or it could be written in the form of part 2, 2x is the image of x under the function of f. Time for us to practice this function notation and look at a few more examples. In this example, write the following functions in function notation using both forms, which are the function maps x onto its answer, as well as the answer is the image of x under the function x. Part A, you will see a diagram, viewers, where the domain contains the values of -2, -1, 0 and 1, and the images that are found are 0, 1, 2 and 3. The relation is to add 2, 2. In part B, we have a relation where x becomes its absolute value of x, and the object values are -2, -1, 0, 1 and 2, while the image values are 0, 1 and 2 only. Viewers, we have to take it to the board and work this out together to practice our function notation. This is our first time practicing function notation together, viewers, so let's take it a bit slow initially, and I'm sure that as we move along, you will begin to be more familiar with the concept and the style of writing function notation. In example A, we notice that every single object has its own respective image. -2, -1, 0 and 1, 4 objects in total, have also got 4 images, 0, 1, 2 and 3. Hence, this is actually a one-to-one relation, which confirms that we do have a function in part A. So let's go into detail now with each object. For example, the object -2 becomes the image of 0 through the relation of adding 2. That means to say, we could take -2 and map it onto -2 plus 2. Similarly, if we try it for another object as an example, let's say we try it for the value of 1. The object 1 is mapped onto 3. Again, through the relation of adding 2, meaning to say that we could write it as 1 is mapped onto 1 plus 2, and so on. Each object in this example is mapped onto its image through the relation of adding 2. If we generalize it and use the letter X to represent the object, what do you think will be representing the image, viewers? As you can see, we can take the object X and add 2 to it, and the answer given will be X plus 2. Hence, the function of f for part A can be written this way. Either we can say the function f maps x onto x plus 2, or the alternative form of function notation could be that f of x is equal to x plus 2, or we can describe it as x plus 2 is the image of x under the function f. Let's try it again for part B. In part B, I'd like to introduce you to this symbol, which looks like two straight lines written vertically, and which we call the absolute value function. Let me just make a note here for us to see. We call this the absolute value symbol, viewers. And the job of the absolute value symbol is to make any number within it only be its positive value. That's why, viewers, you notice that a number like -2 in the object becomes 2 in the image because its positive value is 2. Meaning to say that if the number is a negative value, you remove the negative sign. If the number were a positive value, it stays the same as its positive value. And you can see, can't you, viewers, that a number like -1 becomes +1, while +1 stays as +1. So that's the role of the absolute value symbol. Now, how shall we write it in expression, function notation style? Let's begin with a few examples first. -2 is mapped onto 2 through the relation of using its absolute value. Likewise, 2 is also mapped onto 2 using its absolute value. Do take note, incidentally, viewers, that if we have a case of two objects sharing the same image, we have a many-to-one relation, which is still a function, so we're good to go. And so on and so forth. Back to our discussion here. We notice that if the value were to be represented with the letter X, we should then apply the absolute value to it and write it in this form. Occasionally, we also use the word modulus to represent the absolute value symbol, so don't be surprised if you sometimes hear people saying that the function is the modulus of X. Hence, in function notation form, we could say that the function f maps x onto its absolute value, or f of x is equal to the absolute value of x. Part of function notation is also to be able to write out the domain, the object, the image, the range, all in the proper manner. So let's have a bit of practice with those issues. Determining domain, object, image, and range of a function. The arrow diagram below represents function f. You do see, viewers, in the P bubble, which is your domain, we have the x values of -1, 0, and 1, and these are your objects. The function given is 3x minus 1, and therefore the images that are resulted are -4, -1, and 2 respectively in the codomain of Q. The codomain of Q also contains the value of +3, I beg your pardon, which is not an image of any object. F is a function because it satisfies the following condition. Every object in set P, which is the domain, has a unique image in set Q, which is the codomain. To put it in other words, we see that every object in set P will have only one arrow shooting out from it to hit an image in set Q. Notice that 3 in set Q is not an image because there is no object in set P that pairs with it. Now, having said all that, we are able to identify all the following issues. The domain would be your set P, which is to be written in a pair of curly braces because we are referring to it as a set. And there are 3 items in set P, -1, 0, and 1 respectively. In the codomain, we have set Q, which is a set made up of -4, -1, 2, and 3. Meanwhile, the objects are the values from set P, -1, 0, and 1, and the images are -4, -1, and 2 respectively. We leave out the value of 3 because, as mentioned earlier, 3 is not an image for any of the objects in P. Notice that the range is a set of values again, which is the same as the values of the images. And that is, the range contains -4, -1, and 2. Take a moment, viewers, to compare the two sets, codomain and range. Do you notice that sometimes the codomain contains more values or more elements than the range? And that is true. Hence, we call the range as a subset of the codomain. It could be that the codomain contains more elements than the range. It could also be that the range has the exact number of elements as the codomain. Hence, the range is a subset of the codomain. Take note also, viewers, that the range of a function contains only the images in the codomain. In other words, in addition to what we discussed about the range and codomain just now, take note that the range must contain the values of the images in the codomain. Therefore, you cannot find any values in the set of the range which are not found in the codomain. Now let's try our hand at another example. Determine the domain, objects, images, and range for each of the following functions. And you see 3 diagrams there for parts A, B, and C. Let's transfer these diagrams over to the board and discuss them together, viewers. We have a rather long example here, but a very useful one to teach us or to help us practice how to identify all the various different types of features of this relation. But a few ground rules are necessary first. Perhaps the first thing we should do is to make sure that we are really dealing with functions, meaning to say that all the examples that we are looking at must be either one-to-one relations or many-to-one relations. So let's start by clearing the air with with that issue first. Looking at example A, you will notice, right, that each object value, viewers, finds its own image, okay, and each of them has a different image. So this is a case of a one-to-one relation, and hence we are safe with part A. It is definitely a function because it's a one-to-one relation. Moving on to part B, you will notice that each object has an image, and once again, each object finds its own unique image over here, giving us a one-to-one relation again. Therefore, part B is clearly a function as well. Do notice also, viewers, at the same time, that in the right-hand part of this diagram, we have a codomain because there are some values in this set which are not the images of any objects. Namely, 0.5 is the example of a value that is not paired up with any object. So remember, the difference between the word range and codomain is that range only refers to the values that had objects paired up with them, whereas a codomain may contain more values than the range, for example 0.5. In part C, you will notice the same thing happening, and that is that our codomain contains several more values than the range themselves. And secondly, you do notice that some objects are paired up to the same image. For example, -4 and 4 are paired up with 3, -2 and 2 are paired up with 1. So part C is slightly different in the sense that it is a many-to-one relation. Not a problem, it is still a function, because a function is made up of either one of these two definitions. Right, all that has been cleared, and we're now ready to identify all the 4 types of things or types of features requested in the question. That is, the domain, the objects, the images, and the range. Do take note, viewers, which ones need to be written as set notation and which ones need to be written as individual values? Can you remember? Let's try. Example A. The domain would be this set of values, and as you'll see, I've just given you a clue by saying the word set. Hence, we need to put curly braces whenever we write out the domain. However, objects are just the individual values alone, so you do not write the curly braces here, giving us objects just as -2, -1, 1 and 2. Likewise, images are the results of the objects experiencing the relation, so the images also do not need curly braces because they are just individual values. However, the range is the set in which the images are to be found. So the range contains curly braces, just like the domain did. Right, since we're dealing with the topic of function notation, why not we squeeze in one more little bit of practice and train ourselves to write the proper function notation for this relation, viewers. Now I've made a little bit more space over here, so we could try it out and write it either as the function of f maps x onto x cubed, or the other way of writing it is to say f of x is equal to x cubed. Well, that's how we answer part A, identifying all the various features and even squeezing in a little bit of function notation practice. I'm going to put you to the test now, viewers. Why not you try out parts B and C on your own first? I'll be waiting here to discuss the answers with you, but it's a good thing for you to try it out first. So I'll see you in a very, very short while. And so you're back with me, viewers? Well, this is a time for you just to check your answers with what I'll be writing on the board, because I'm hoping that you've already completed parts B and C. The domain for part B would be 0, 60, 90 and 180. Meaning to say that the objects are 0, 60, 90 and 180 minus the curly braces, because as I mentioned just now, objects are just the individual values while the domain is the set of the object values. There's something rather interesting in part B, viewers. You do notice that the function that is involved is to find the cosine of the x value and add a 1 to it. So in the domain, the x values are just numbers, but in the range or the image or the codomain, whichever one you want to call it, we have changed the x values into degrees in order to perform cosine on them. However, you do not need to write the degree bubble symbol to the 4 values because it has been defined as x here, while the function changes it into x degrees. So that's just something interesting for you to take note of. Moving on, what are the images associated to our objects? Well, we have 0, 1, 1.5 and 2, and that creates the range of these 4 values as well. Did you also practice your function notation? Let's take a look. We should be expressing the function g as mapping x onto cos of x degrees plus 1. That should be the way to write it out. Or alternatively, g of x is equal to cos x degrees plus 1. There you have it. Shall we go to part C now then? Let's take a look at what the domain, objects, images, and range for part C are. Over here in the domain, we have 5 numbers which are -4, -2, 0, 2, and 4, giving us those same 5 values as the objects. However, the images only turn out to be 3 values, simply because of the function involved. And so the images are -1, 1, and 3, producing a range of -1, 1, and 3 in curly braces. And finally, viewers, your function notation should be using the letter h. It maps x onto the absolute value of x minus 1, or alternatively, h of x is equal to absolute value of x minus 1. So viewers, were you able to answer the examples on your own properly? I do hope so, and I hope that now you have a clear understanding of what are domain, objects, images, range, including codomain and function notation. In this lesson, viewers, we've had some practice on identifying domain, objects, images, and range. We've also had practice to recognize the difference between range and codomain. And finally, we've also done quite a lot of practice on writing out the function using proper function notation. So do join me again next time, viewers, in our next lesson where we are going to continue more discussion on functions. Do take care for now and happy studying. Goodbye from ITTV.